Hello. Hello and welcome to the second to last week of Art 107. Hi everybody, thanks for coming out in the snow. It's actually pretty pleasant out there. It's not too much. So I do want to, I had a couple of questions, both kind of in person here and over email about the last couple of weeks of class. So I want to just review the calendar or review our kind of plan for the next couple of weeks. And then we're going to spend today talking about iteration, also known as for loops, also known as a way to do a lot more with your code. So before we jump into that, though, I want to talk about this week and next week and the week after. So this week, I'm going to be, obviously, I'm demoing today, I'm demoing on Thursday, and today I'm going to show you sort of a really essential code concept called iteration that you certainly will be able to use in your next assignment, the Interact assignment. Then on Thursday, we're going to be jumping into strictly like UX type stuff, how to use the mouse and the keyboard and how to sort of like interact with the code that we've made. So we'll be focusing mostly on interface stuff on Thursday. And then on Tuesday, again, Tuesday is sort of like a little bit of a flexible day. I have some slides to show you. And I also, based on those slides, have some kind of advanced examples that you may have already seen. I'd like to at least show you what they are and what they do so that you can kind of get an idea of what you may be able to do in the future with code. Also, I think that on Tuesday, if there are any sort of like general questions or issues that people need to talk about, we can take some class time to, just entertain questions. So if you're watching from home or maybe you're even here in the room, don't be afraid to sort of like email me some of those questions ahead of time. That's kind of a good way, for me to prep. I don't need the questions to be emailed to me ahead of time, but if you ask them during class, you might get a slightly less thorough answer. So yeah, that stuff is all happening. As you all know, hopefully, Wednesday the 14th is our last class day. We are not having class on Wednesday, obviously. Our class is on Tuesday. So this week 15, December 13th, Tuesday, is our last class meeting in this room. I will be sure to tell everybody who attends on that day that this is our last class day. So just so you know. Then we do have finals week, which, as I've pointed out, I think before, finals week is a bit later than it usually is. Don't know what that's about, but we kind of have to just deal. And our final exam will be online, very much like the midterm in terms of time and in terms of the structure of the exam. And that is on December 22nd. December 22nd. Okay, I want to make sure that everybody knows that. So, and then if you're thinking about turning in assignments late, obviously it looks like the due date for our Interact assignment is on the 12th. If you need a couple of extra days for some reason, like maybe you have some sort of like illness, COVID, or maybe you, just are like overwhelmed and behind, and you're asking for extensions, the furthest that we can extend deadlines and be able to process grades is to have things in on Friday, December 16th. Your TAs may have given you dates that are even a little bit ahead of that. If that's a problem, let me know. I can always, step in and do the work of the TA if you want to turn something in on the 15th or the 16th. But the absolute last day that you can turn things in is on the 16th. And that's coming from the rodeo master here. So I guess I should say rodeo mistress. Anyway, that's kind of all I got as far as like general updates. Does anyone have any questions about sort of like the mechanics of the next 2 or 3 weeks? Okay. I also did want to mention that I do think that there is a very strong possibility that I will put a video final review here, right here, slot. There's a slot already created for it. So I will be making a short video that just addresses the final exam. I probably will not be using class time to do that. I'll be putting it up as an additional video. But there will be a final exam review very similar to the midterm review. All right? Okay. Any last sort of housekeeping type scheduling questions or anything like that? Okay. Any code questions? Dum, dum, dum. Dum, 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 dum. All right. So I do want to point you to sort of the slides that we're working off of right now. So in the Intro to Coding in P5JS Part 2, and then also in the Part 3 are sort of the slides that we're working from for this week in general. So if we look at the section, the Part 2 section, I just want to show you all this stuff so you know that it's there. So we got into variables, iteration, and conditionals. And this is the kind of stuff that we were sort of thinking about when we made our example last class, which, as you recall, was an example where this sort of ellipse got captured kind of within the window and was moving from side to side, right? And we used conditional statements in order to do that, to limit the x-coordinate of the ellipse. So this sort of purple section right here, this sort of purple section of these slides is what we're going to be talking about today. And we're going to be talking about this sort of primarily. It's kind of a big, heavy, important concept in coding. Can you code without it? Sure. But that's sort of like asking somebody to like make, like puff pastry where they blow each bubble by hand. It's not very pleasant. So what we're talking about doing is we're talking about this concept of iteration or repetition. And I'm going to go ahead and just get straight into the editor. I just wanted to kind of take the opportunity to show you where those slides were if you're looking for the sort of like long textual explanation. So this should all hopefully look familiar to you. Let me go ahead and date this and save it before I move very far. Let's see. Oh my God, it's December. I can hardly believe it's December. Okay, so as I said before, this should all look familiar. One thing that I want to point out is that the examples that you're doing on your computer could possibly be quite a bit larger in terms of the pixel size. I don't really care what size you work with as far as like what you turn in. My sort of probably only maybe caution about going with like, let's say you wanted to, I already have to warn you in advance. I wrote a bunch of emails before class. I'm having a terrible typing day, like all over the place. So let's just make, I'm going to make an HD video-sized frame, which is pretty, this actually tends to be the size that I work in the most. And I do it on my home desktop computer. So you can do that, but in this environment, it doesn't work all that well because then you kind of have to scroll through to see stuff. So my advice for all of you kind of in the framework of this class is to work with a window size of probably 800 or less. So if I just go back to our original canvas size here, I'm going to actually leave this at 400, 400. I'm just kind of talking about this because you're going to be turning in another project, and I want to give you some options. So with a scale of like 800 by 800, you're not super likely to like have enough pixels being drawn at once to kill your computer, or to be able to like maybe fry an egg on your keyboard here. When you start working with larger pixel loads, I mean, it's just kind of common sense, right? That this is moving maybe, hopefully at 30 frames a second or more, and it's having to draw 2-3 times as many pixels. So the pixel size is one of the largest sort of ways that you can kind of tax out the laptop, is just by the sheer number of pixels being drawn. So if you're looking for something that's going to run really fast, I would keep your pixel size like under 800 pixels. If you're an advanced coder and you're using like something like, and really any kind of text editor to work within a web server, that's sort of a more advanced technique, but you can kind of take over the browser window with P5, which can be really cool. But again, it's just more pixels, so you have to think about like how much you're drawing to the screen at once. So I'm giving you this speech, by the way, because what we do today is going to start giving you the ability to draw all the things. And when I say all the things, I mean capital A-L-L, all the things. And then things inside of things, inside of things. And it's like going to get Inception-y, if anybody's ever seen that movie. Anyway, so yeah, so let's move on. So right now it looks like I have a 400 by 400 window. That's just fine for me right now, but if you, again, that's something that you could maybe play with on your own setup. We have nothing special here is happening, right? We have the draw function set up. We have a background that we're calling. It's some boring gray color. I also called the no fill function, so you can see our little shape here is being drawn without a fill. And we have a stroke of a black stroke. So you can see that here is reflected in this thing. And so what I'm going to do right now is I'm going to do like a tiny review of what we've already done to kind of get us to a place where we have something to sort of improve on. So you can see I kind of knocked everything down, kind of being careful to preserve this curly brace at the bottom that's part of the draw function. And I'm going to take this one ellipse, and I'm just going to copy it like 10 times. And hey, guess what? It's like a cooking show. I totally already have this done. So you don't have to watch me type. I know how utterly thrilling that must be, but today we're not doing it. Okay, so what I've done here is I've set up 10 ellipses, and this still is not very exciting. This is like well within the boundaries of kind of what we've been looking at for the last couple class periods, right? So as you can see, they're stacking on top of each other. Why are they stacking on top of each other? Well, it's because this y coordinate is increasing in a very regular way, right? And in the sort of spirit of like stating our problems in sort of natural languages, by that I mean like spoken human languages, I'm going to go for English. What are we trying to do here? What is happening with that y coordinate? It's having something added to it. It's a number, yeah. Having 10, yeah. It's having 10 added to it every time the ellipse is drawn, right? So that's pretty easy for us to sort of like wrap our brains around, right? Like it's just moving, getting drawn at a lower point. So now people will come to me, and with your very first exposure to coding, somebody would ask me maybe, is this the right way to do it? And I would say, you just learned to code like yesterday? Sure, good job. However, if you learned to code maybe 2 weeks ago, we could do a little bit better. There's a much more efficient way to do this. And so what do I mean by efficient? Well, I don't necessarily mean the speed at which the computer takes to draw it. That's actually about the same. But it's efficient in terms of typing and in terms of setup. So you can see right here we have about 10 iterations of the ellipse object. If I comment these out, I can take this block of 10 items and I can condense it to 3 lines of code that can be, and this is, I'm going to throw a big word at you, parameterized. And so those 3 lines of code can be basically parameterized into a line where you can adjust the parameters. And so don't worry if you don't get it. We'll talk about it at length. So what I'm going to go ahead and do here is I'm going to make what's called a for loop. And I'm going to just steal my pre-drawn one here. So a for loop is really a way of taking a process and giving it maybe parameters in order to, I'm sorry, I'm a little bit messed up because of the cut and paste here. So right now there's nothing in this for loop, but the for loop, just like a function, you can see there's sort of like a control statement, and then this is the actual for loop. And then in here, we'll go some statements. Now, right now, I can tell you the way that this for loop is set up right now, nothing's going to happen. It's just going to draw one ellipse. Oh boy, that's exciting. Well, don't worry. Let me kind of explain the way that this works to you, and then we can sort of think about how to really implement this ellipse in this for loop. So probably the best way to do it, rather than jumping straight into the ellipse, is to notice that as part of the for loop, there's a variable that is being declared. So there's this like temporary storage box called I, okay? And you may notice in for loops that I is pretty conventional. You can use literally any letter or number or any variable name you want. You could call it like my terrible vacation. I don't know, like whatever. It can be anything. The reason that people use I in this situation is because these loops are so common that it's just literally like the least amount of typing. So it's a single letter. Now, the other reason people use I, and I feel like this is interesting to think about and also interesting for you to know, the reason that I and probably J and then K are used really commonly in these loops is also because they're not a very key variable known as X or Y. So it's really common for sketches to have X and Y variables. And so one of the reasons that people tend to use I inside the for loop is because it's not used for other things. So it's one of those kind of programming conventions that it might seem arbitrary, but there's actually like a good reason for it. So I usually stick to I myself. Now, the question that we want to ask ourselves here is, inside of this for loop, what is I? So if we look at I here by printing to the console, okay, well, this looks pretty basic. It looks like I is a number between 1 and 400. And if we look at these other 2 statements inside the for loop, you can see why. So here we create I, it has a value of 0. Okay? Then the next statement is called a test. I'm actually going to write this down here for your convenience later. I'm going to stop that just so it quits iterating. So the first part of your for loop is the declaration, and that's usually I, but it doesn't have to be. And then you have what's called a test. And then we have the increment. And so in this particular for loop, our test is to see if I is less than height. Height happens to be 400 in this case. So it looks like I is going from 0 to 400. And what's allowing the value of I to climb is the decrement. Or in this case, excuse me, it's the increment. Usually, 95% of the time, the for loop is set up with either an increment or a decrement to change the value. In exotic cases, I have seen people use multiplication and division and all sorts of other math operators in for loops. We're probably not going to do that. It'll just be kind of confusing. But 95% of the time, it's usually just a single increment. So this adds 1, the number 1, to every instance of I. So probably what's happening here is we're saying, okay, I equals 0, and then it's a little bit out of order. Then it adds 1, and then it checks to see if it's less than height, right? And then it executes the statements inside of itself. Then this, once the for loop is initialized once, it does not declare again. The declaration is done. So this is sort of like X'd out, this part, for the second loop. For the second loop, it's adding 1. So now it's 2. And then it tests, is it less than height? Still not. And this will go on infinitely. Is it possible to write an infinite for loop? It is. It's a good way to lock up your entire computer and maybe get the fire hose out. It can be pretty crazy. So how would we draw an infinite for loop here? Probably there are a couple things that can cause you to have an infinite for loop. One is if this test is always true. So if you said something like, if I is greater than 0, yes. In this situation, I will always be greater than 0, so that would make the for loop always true. In general, that's a bad thing. You don't want to do that. You want to use that test as a way to stop your for loop to keep it from running forever. Because we could make this like a really high number. Let's just make it like 100,000. And it will do what we tell it to do, hopefully. It's taken a while. Well, I probably locked it up already. Let me give it a smaller number. Okay, this is sort of like the limitations of the web browser. I'm just going to use some numbers to sort of, some slightly smaller numbers to illustrate the point here. So it looks like there's something a little bit wonky with the for loop, actually. So this is sort of like just a troubleshooting thing. As you can see, I'm printing to the console, and then at some point I lost the ability to print to the console. So I'm guessing that there's probably just some sort of like small like syntax error, like maybe one character off or something. I'm going to set this back to height. My computer right now also feels like it's like getting a little breathy. Like it's like doing that thing where you can hear it, hear the fans. That's always healthy. And it's also running super slow. So I can tell you for absolutely like 100% certain, it's not supposed to be this laggy. So there are a couple of things we can do. I'm going to just sort of preemptively do a select all and copy my code. Because let's say my trust level in this online editor is not 100%. Probably what would be a good thing to do, just because it's being so super laggy, I could certainly get rid of some of my applications so that Chrome has a little more room. Just going to get rid of some stuff here. real quickly before we kind of move in here. Thank you. Okay. Oh, it's my whole computer looks like. It's not just that window. I'm going to see if there's anything else that I can shut down here. Oh, Photoshop. Hello. Okay, well, hopefully that'll buy us a little bit of flexibility. I'm just going to switch to this window in case the browser window was indeed having an issue. Although it does really still look like my entire computer is just kind of bummed out. What happened? So when you're running P5, one thing I just checked was the amount of hard drive space I had available. Probably like 20 gigabytes is, getting into the danger zone. So my hard drive is pretty full right now, but I really don't think that that would be the problem. And it looks like, now I'm sort of like freed up. So I guess my computer just had to think really hard about something, and now it's functioning normally. So yay, that's helpful for what we're doing today, which is doing stuff. Okay, so now we were thinking about choosing sort of other numbers for this test. And so right now you can see we're testing height, and it's limiting the value of I to 400, which is our height. We could also think about using something like a nice decimal-y number, like 100. Why, does anyone want to tell me why the metric system is so popular and so awesome? Because you can divide things by 10, yes. It is awesome, and using powers of 10 in coding is just really easy to think about, and it's really convenient. So I would encourage you to do that. Also, if you're thinking about, this is a fun trick that an artist told me once. If you're thinking about, changing around your sketches and you're using decimal sort of, powers of 10 decimal numbers, you can always add a 0 to make it go faster, slower, bigger, larger. Just add some zeros and see what happens. It's a good way to kind of take your code and just make it go crazy and get something different. So let's start drawing this ellipse. So what we want to do in this case is we're limiting the ellipse to 100. So we could go ahead in here and use I. So what do I mean by use I? Well, it seems like we sort of already set it up with this sort of expression here, where we have 10 plus 0, 10 plus 10, 100 plus 20, 100 plus 30, and so on and so forth, right? So what we could do here is actually sort of sub in I. And in this case, because I is a function of 100, we could say I divided by 10. And then let's see what happens here. Okay, so as promised, I think we got the 10 ellipses. They're not very far apart, are they? So let me just double check some parentheses here to make sure that we're doing that correctly. And yeah, so 100 plus I, actually, in this case, let's go ahead and just use I sort of by itself. Okay, so now we're sort of drawing, and the I is basically shifting that down, right? So in this case, I think what we would want to do is I times 10, maybe. Okay, so actually, we're getting every single value between 0 and 100, right? So probably, instead of maybe using this 100, there's like a billion ways we could do this, basically, but I'm just trying to think about the sort of most efficient way. So it seems like I'm going to go ahead and just draw it straight at I and see what happens. That's kind of the simplest way to do it. So, okay, so you can see here that it's drawing, how many ellipses is it drawing? That's my question for all of you. How many ellipses? So every time it loops, it adds one to the number, and then it tests, and then it runs the statement. So in this case, the statement is the ellipse. So in this case, right at this moment, it's going to draw 100. This is 100 ellipses, and that's why they look so close together, is because the value of I is just 1 through 100, right? So every time the for loop hits a value, it prints an ellipse. So basically, right now, it's going from 0 to 100, and it's adding 1 with every iteration. Well, let's say, for the sake of argument, that I wanted, instead of 100 ellipses, that I wanted like 50 ellipses. So in that case, I could do, instead of incrementing it by 1, I could increment it by 2. And let's see what that looks like. So you can see it's a little thinner, right? I could take this even further and increment it by 10, which will probably get us closer to where we want to be. And now you can see it's sort of exactly this. It's at a different location, but I did that on purpose. But it's exactly the same as the code that we had before. So basically, like, what you have is, like, this has now changed to this. And it's literally exactly the same thing. We could do 100 plus I to make it exactly the same thing. And that'll shift it down. So now these are going to give you the exact same results. So that's great. Okay, what else can we do with for loops? Well, I'm going to spend the next couple of minutes telling you. So I think I'll keep that in there. Probably another really great thing that you can do inside of a for loop is to work with the size. Sorry, I'm still having some lagging problems. So in here, let's go ahead and try subbing in I for the size of the ellipse. And we'll just see where that gets us, and then we'll adjust accordingly. Okay. So yeah, that sort of drives it home maybe a little bit more, that you can see literally that the value of I is increasing. In this case, it's increasing through, if we look at the console where we're printing the value of I, it's increasing by 10 every time it runs, and then we're adding that 100 to sort of just get it down into the screen. Personally, when I'm coding stuff, I'll just tell you, I like to code towards the origin. So what that means is I like to code basically starting things at 0, 0. So right now you can see we're starting things at 0, 0. I'm going to show you another technique that you can use to kind of take like everything that's drawn on the screen and shift it to the center of the screen, which can be super useful because, I mean, I guess you can probably tell, is it easier to do math from 0, 0, or is it easier to do math from width divided by 2, height divided by 2? It's way easier to do it from 0, 0, because 0 is nothing, right? So yeah, so let's go ahead and do what's called a translate. And I'm going to translate it to width divided by 2, height divided by 2, which is always the center of the screen. There's going to be one other thing that we have to do to get this translation to work, and it's going to look a little bit strange. So just going to warn you in advance that this might not look the way we kind of plan it to look. So right now you can see it's static. I think that there's something that you should consider doing when you use the translate function that's basically called the push and pop method. And it's kind of like a really long technical explanation, but the push method basically opens up what's called a transformation matrix, and then the pop closes it. And what this helps with is it helps with things inheriting transformations. So it's not really important right at this moment that we use it, because you can see that it's kind of sitting there nicely. But when we start adding in motion and other stuff, it's really important to have that push and pop in there, because otherwise the math will come out wrong, basically. So I'm going to just run this one more time. And probably, I think, in order to maybe amp up the excitement level right now, I'm going to create a variable called r, and I'm going to create it with maybe 0.1230005. So it's a really small number. Rotation values in P5 are calculated in radians, which is using 2 pi as a system variable. So it's going to look a little bit different. And in general, that means that 360 degrees is equal to 2 pi, which 2 pi is 6.23 whatever. I'm not one of those people that has all those numbers memorized. Yeah, it's 2 times pi. So that's the maximum rotation value in processing and P5. What you might notice is that those are basically 1 degree comes out to be a really small number. So if you want things to rotate slowly, they need a lot of zeros. So let's come in here. I'm going to make a little note to myself that that's for rotation. And then inside the for loop, I'm going to use the rotate function. And I'm going to rotate by r. And this is not going to do anything, by the way. I'm just going to illustrate that. Oh, it did something so imperceptibly tiny that we are not able to see it on the screen. We just rotated it by 1/4 of a degree, right? That's not very exciting. So what we need to do is maybe also inside the for loop, we're going to take r, and we're going to make r equals r plus r. So what I'm doing is I'm basically just increasing the rotation value with every iteration. So let's see what that does. Exciting things. So basically, I think probably I'm going to take this increment out of here and put it just in the general loop, maybe down here by the pop, but I'm going to keep it inside the pop. Should keep it running constantly. So you can see, oh wow, new stuff has come to light. What has happened here? Well, what has happened is basically that this rotation function is iterating pretty steadily. So my computer is still super laggy. I'm sorry, everyone. This is kind of killing me a tiny bit. So let's go ahead and think about this again. I'm going to stick this down here. So it is somewhat interesting to me that what we're looking at is not constantly rotating. So that would be my expectation, is that this should be constantly rotating. So I'm just going to double check what I did last time. Nope, cannot do. So, probably, let's see, what are some of the things that we can think about doing here? So, I'll tell you what, I'm going to not deal with the rotation for now. I'm going to show you another concept related to for loops. One of the reasons why I think it might be best not to deal with rotation right now is because my computer is not performing as I would expect it to. And rotation is, or any kind of animation is definitely probably not going to go very well. So basically one thing that I would like to show you in the last 5 minutes of class is how would we take this sort of group of iterated things and say, if this is a row, how would we make columns? In other words, how would we turn it into a grid? And this is where it kind of becomes seriously interesting. So you can click under the for loop, and I'm going to instantiate a j this time with a value of 0. And j, let's say, is also greater than or equal to 100. So I'm setting it up pretty much in the same way as the outside for loop. But what this is going to do is this is going to give us the appearance of rows and columns. And if you're wondering how coders work with spreadsheets, this is definitely one of the ways. Sorry, this keyboard is not doing what it's supposed to do right now. So you, of course, need to keep in mind that it's definitely calling, we're putting the call to ellipse, and we could probably also put the call to I, if we wanted to, inside the J loop. And definitely you need to keep in mind that these curly braces are sort of wrapping around, that the outside curly braces are wrapping around the inner curly braces. So it's like a sandwich, right? You have the buns, and then you have the patty, or whatever. But in this case, this is going to look exactly the same as what we already have right now. And the reason it looks exactly the same is because we're not using the value of j right now. But if we wanted to take this 0x coordinate and sub in j, other things will happen. Oh, hello. So that's basically how you make a grid. And I have an example for a 3D grid where you use x, y, and z. And that's on the website for sure. So yeah, now from here, if we wanted to take this rotation function and stick it in here, it's going to look a little bit different. So yeah, as you can see, it's super subtle, right? It's just barely off kilter because we're not incrementing it. In this case, we can just increment it down here. And it gets even more fun. One thing that I kind of want to do here is to instantiate a frame rate object. I think that the reason that this is so laggy is because my computer is just not behaving, but I just want to double check and make sure. So this is sort of forcing the issue, forcing it to run at 30 frames a second. So yeah, pretty fun. I'm going to double check just all of my things here. So I'm a little bit quizzical as to why it stops rotating. That doesn't really make a lot of sense. So I'm just going to show you what I would do if I were you. After the value of, after this increment of r, I'm going to print r to the console. And I'm just going to get rid of whatever I previously had printing to the console, which I believe was the value of I. So I'm going to comment this out. And I'm just going to test it one more time and kind of try to figure out what's happening. Okay, so this is actually a really good problem. Basically what's happening is that the number is getting so high and that it's sort of like, what kind of crazy scientific notation is this? So that's actually like, if you start seeing things in scientific notation, that is not usually a good sign. It just means that the number is like going off into the ether, right? And processing probably, or P5 probably can't draw it. So in that case, probably what we need to think about doing is maybe like adding r divided by 10. That's one, there we go. So that's one of my like favorite code moves, is to like divide or multiply something by 10 if you want to make it really bigger or really smaller. It's a good strategy to kind of fix things. So yeah, it's like sometimes you kind of have to work through, you know, how things are flowing through the code, but there's almost always a solution. If you want to, I'm gonna put 2 examples up today. I didn't get quite as far as I wanted to because of the, you know, the computer uhs. But I have the example that we worked on in class. I'll definitely post, and then I have like an example of this that's like slightly further along that actually uses the for loop to change the color as well. So, so I'll post both of those to the course website later this afternoon. I probably won't have time to post the course video. Oh, you don't care about the course video, you're here. But I probably won't have time to post it until later. So, hey, I'll see you all again on Thursday, and yeah, we'll kind of just keep working through it. All right.